longest palindromic substring. Quite a common question, but not an easy one. So let's get started here. What is a palindrome? Well, it's just something that when you reverse the string, so if I spell BAB backwards, I get BAB. Common examples are like race car. If you flip this and spell it backwards, you get the same thing. If you just had to solve this problem, what I'd recommend doing is having two pointers at both ends and checking is both these ends equal to each other. If they are, perfect, let's move in the middle. And this will be in a while loop, so while L is less than or equal to R, we'd essentially then check is A equal to A? And if that's true, perfect, return true, that's a palindrome. Now this is a perfectly viable approach. They complicate the question a little bit by adding the fact that you might not get a palindrome from the first word, but there could be a smaller word in the bigger word. And that's the sub-problem almost of having to figure out, hey, D and B don't equal each other, but we still want to keep checking. Now, you could do this with the same two ends approach, and what you notice is you'd have one for loop that would start L, and you can check every single starting position of L, and that would run through the string, and then you can have one for loop inside the L for loop, checking every position of R. Now you can see we're getting this n squared nature, and then the last check would be this while loop that's going through and making sure all of these are equal to each other, and that would be another, so an O, big N of O approach. And obviously, this might work for some interviewers, please check, but you would have to essentially make the argument of why this is the best solution you can think of. What I would recommend is this simple trick where instead of starting at the ends, what if you start in the beginning, right? What if you just have L at the same place you have R? And that's the kind of key insight to this problem. So first you'd move L to the left and R to the right, but the first check is basically, hey, is B a palindrome? And obviously every word's spelled backwards is a palindrome of itself, so this would be out of bounds and we could stop our iteration, but we'd record B as the longest answer we've seen so far. And just a brief aside, I like writing the editor because when you do HackerRank or CoderPad interviews, you're not going to have something to draw with. So I like these little diagrams because it's more realistic of an actual interview simulation. Now, let's look at A. So now we have a for loop that moves our starting indices to A, and then we get to basically check, hey, is A a palindrome? Well, it is. Perfect. Let's keep expanding from that center point, and then we can check is B and B a palindrome? Perfect, it is, and then we can expand our answer because now our current answer we found here is longer than our previous answer. If that all makes sense, let's code up the solution, and there's different ways you can code this up, but the way I like to do it is in one for loop and then expanding centers in different areas. And the reason I say one for loop is you can do two for loops because there's a little bit of an annoying edge case of even numbers. Well, you know, BB might be the best palindrome here, but you're never going to reach that because you're expanding here and you're expanding here because they're starting at the same point. If you expand here and you check, hey, does this end of B equal this end of C? Well, it doesn't. So you completely miss this edge case. Well, for those situations, we can essentially start one apart. And also, this doesn't just apply to even versus odd lengths. Let me make that correction, because you could have something like BBB, and if you just started with these together, actually, sorry, so you say it's an odd length, that was an even length, and you started with these together, you might never hit the BB case, because your L and R, when you go to expand, this might be out of bounds, you missed that case in this example. Or for here, you might hit this case, and you hit this case, and you might go out of bounds. That might be overkill for how much we can explain during an interview, but I think that's an important distinction just for yourself to know why it's not even versus odd situations. Okay, perfect. So let's start coding here. What we can do is have an answer equal to an empty string to begin with, and return that answer if it's true, and then we can have a function. So define is palindrome, and it takes two arguments. It takes a left pointer and a right pointer. And while left is less than or equal to right, and we need to check if L is greater or equal to 0, and R is not greater than the ending string, we're in bounds. And then if the string of L the character at that point in the string is equal to the character at the point in R, we basically have a potential answer. So if this is true, and basically L minus R plus 1 is greater than, and you need this plus 1 because indices are 0, indexed. If that is greater than basically the length of our current answer, well, we can just set answer equal to that string. And of course, Python, your strings are, when you do the slicing, it's not 0, it's basically exclusive of the end. And one other factor I forgot to mention, if you want in your closure to mutate the state of a variable outside it, you need to put this non-local. And so that's going to be your answer, and now we can actually mutate and return it here. Pretty simple, algorithm-wise. A few caveats you need to remember to do this. Please remember the non-local, and it's much better than doing in other languages too. And lastly, we need to simulate both starting at L and R, and this is why I said you can have 2 for loops doing this logic. But if you pass in L and R here, and just do I in range basically all the way to n, and let's just grab that as something is equal to length s. So now we can also replace this. And feel free to just keep modifying your solutions. I'm thinking of clean solutions in the interview. I promise you will impress the interviewer. You can send the I and I as both starting positions here, or you can send it in as I and I plus 1. Great. So now you have these 2 starting positions, and always good to double check your work. Now you're assigning it to answer. If this breaks this longest condition, and it's L is less than equal to R, so that works. Let's give this a run. And I always like to just do this live, and I don't have like most YouTubers an answer on the side, because I want the like authentic coding experience and debugging, because it's not always going to run initially, and then like this, it just broke, and you need to figure out why in the interview. So let's see. So time limit exceeded. So this is the palindrome. Oh, one thing we did forget. So when I see time limit exceeded, I think to myself, some infinite loop, and the only way we can have this infinite loop is this while condition. So when I do L minus 1 and R plus equals 1, then I'm realizing I was actually not moving these forward, so of course this will always be statically the same thing. Okay, great. So now we are getting somewhat of an answer, but it's not the ideal answer, that's fine. Let's go investigate why. So if L is less than equal, if S is equal to R, this is both starting at the same position, BAB. And then, okay, so that makes sense. And the output is B. We never got the correct output. Oh, these are just some extra edge cases I added. But this is the other case where it's C. And we're still not getting the ideal output. Interesting. And then if your interview does allow, which sometimes they do, you can start printing out the answer at each moment. So that's not too useful. But we can try and see what this might be at each stage. So we are getting BAB and exploring that string. But it's just not saving as the answer. Interesting. So I want to see why not. Because clearly the length isn't bigger than this whole string, right? So, and we are getting it here as well. It seems like the answer is getting overwritten for some reason. Answer. Oh, I see why. So, yes, it should be R minus L. Because L minus R, we are getting some numbers that are mostly not going to be accurate, because we're comparing a weird negative scenario there. And we could explore why, but I don't think there'll be too much value, as that's just my mistake right now, not a common mistake. Perfect, let's see if that submits. Ooh, we did get one test case wrong. That's fine. We can dive into that as well. A C A A C A B D K A C. It should be A C A. And I outputted the whole darn thing. I wonder why. So we're always starting from the center, right? And if that's equal to that, then that should be the output. Not exactly the whole thing. Yeah, because clearly this isn't a palindrome. So there's no way we could have started from the middle and got the whole thing as the output. Let's use this as a test case and let's print how we got to that situation. So we a couple of times do enter this loop with that as the whole string. But obviously that's not what we needed. Just gonna double check this. As you can see, we are expanding ACA. This should have never been a palindrome. Oh, this is a bit concerning. ACA. Because I guess the ends could equal each other, but the beginning shouldn't have. I forget this else condition here. So else, if we did find something that's invalid, we should just break. But even if this was invalid, we were just allowing our loop to continue going, which is not what we want. Perfect, perfect, perfect. Amazing. And the runtime of this is actually n squared, and the space-time complexity is O of 1 because we're not using any extra space. You could argue that we're storing O of n space in the string answer, but semantics. And I definitely thank you for being patient while I debug this. I definitely want to show sometimes the struggle you face in interviews, and then what's the best way. Just not panic and work your way through the problem. So thank you so much. See you next time.